Every day, at least 1.2 billion selfies are taken with the camera. That's a lot if you think about it.
To be honest, I actually never really understood how DSLR cameras actually work. Would you mind explaining to me?
Okay, Sheil, I don't mind. Let's start off by defining what a DSLR is. DSLR stands for Digital Single-Lens Reflex Camera.
Oh, wow. Does it have reflexes like Chuck Norris?
No, Sheila, it doesn't have reflexes like Chuck Norris. You know what? Let me explain using the anatomy of a camera. Let's start with the most important part, the lens. The lens used in these cameras is a thin convex lens, otherwise known as a converging lens, which we learned in science converges all light rays to one point, called the image point.
Oh yeah, I remember Mr. Abada talking about that. Was there something about the focal point? Like where the image is the same size, inverted, at twice the focal length, and the image is real?
Although all cameras use convex lenses, different types of camera positions result in different types of lenses. But we'll be talking about the normal, wide-angle, and telephoto lenses, and the different types of images that they form.
Oh, how about we start with the normal lenses?
This image is what you would see of a scene with a normal lens. For all lenses, the light enters through a small hole in the lens called the aperture, where all the light is focused into the aperture and enters the lens.
Oh, aperture? I know about aperture. Normal lenses have a wide aperture. Aperture is the amount of light that the lens allows to enter. A wider aperture will result into a more magnified image, while a narrower aperture will result into a less magnified image. Along with the apertures of the different lenses, these lenses also have a wide range of focal lengths, and these focal lengths are indicated by millimeter markings. A normal lens typically has a focal length of 55 mm, as you can see from this picture. Not only lenses have a focal length, even our eyes have focal lengths as well, and this is because our eyes actually have lenses in them. The focal length for our eyes is 50 millimeters, and which is very close to the focal length of the lenses, which is 55 millimeters. This results into a very similar image.
That's right, Sheil, you're getting a hang of this. That's our normal lens. Now let's talk about our abnormal lenses. Man, I wonder who came up with this lame script. The next lens is our wide-angle lens, aka the abnormal lens. A wide lens has a narrow aperture. This results in a lot of light entering the lens through the aperture. Now, let's take a look at the image formed by a wide lens. As you can see, due to the narrow aperture, a lot of the scene is shown, more than what the human eye can see. Let's compare the focal lengths, apertures, and images for normal and wide-angle lenses. The wide-angle lens has a lower focal length, narrower aperture, and a less magnified image, meaning that you can see the tree and its surroundings. The normal lens, however, has a higher focal length, wider aperture, and a more magnified image, meaning you can only see the trunk of the tree.
Oh wow! So does that mean with a wide lens I can take a selfie with all my buddies?
Yeah, sure, but you take selfies with the DSLR?
Yeah, of course. Don't you know? So we're done normal and wide lenses. So what's the third type of lens? Telephoto lens, right? Yeah, I heard they use those in FIFA and other sporting events.
That's right, Sheil. Telephoto lenses are used for close-ups from long distances. Telephoto lenses are long. Telephoto lenses have a focal length of at least 200 millimeters. The aperture for a telephoto lens is also very wide, allowing a lot of light to come in.
Oh, that makes sense. So as a result of this, the image will be very magnified, not showing much of the surrounding, but just more of the cloud.
Wow, Sheil, you're really getting a hang of this. Now that we've outlined the different types of lenses, let's take a lens overview. Get it? All lenses are made up of convex lenses, but their varying focal lengths change the image characteristics. The telephoto lens has the highest focal length, widest aperture, and very close-up and magnified picture.
The wide lens has the shortest focal length, narrowest aperture, and produces a very, very wide image.
The normal lens has a focal length that is in between the wide lens and the telephoto lens, and it has an aperture that is close to the eye. By knowing the different types of lenses and the images they produce, photographers can take effective photographs, or selfies. Right, Sheil?
Yeah.
Now we just looked at the three basic types of lenses, but having a fixed lens like those isn't going to help in photography. That's why we have zoom lenses. These zoom lenses have multiple focal lengths, which allow for different zoom levels, different magnifications, and different size of images. With just a twist of a hand on the lens, you can have a variety of zooms or focal lengths and change the image size to your liking.
Okay, so could I explain this now?
Sure, go ahead.
Okay, so for example, an 18mm focal length for a wide lens produces a wide image showing the whole scene. A 55mm focal length, which is the focal length for a normal lens, zooms into the scene a bit more, showing less of the surrounding, but more of the tree in this case. Lastly, a 200mm lens, which is the focal length used for telephoto lens, has a very close-up view of the scene, not showing much of the scene and focusing on mainly the subject. That's all for lenses.
Shield, that might just be it for lenses, but the selfie you post on Facebook doesn't just happen like that. There's more to a camera. Just keep watching. The second part in this camera is the reflex mirror.
To add on, this reflex mirror acts as the plane mirror, and it follows the laws of reflection, as we learned in the optics unit. This law basically states that the angle of incidence and the angle of reflection are exactly the same. So yes, I'm getting this now. Wait, but I have one question. Why is the mirror placed at a 45-degree angle exactly?
Good question, Shield. The reason why is that you want to see the image through the viewfinder before you actually take that picture. That's what the reflex mirror does, by basically making sure that the incident ray is reflected towards the matte focusing screen. The third part of the DSLR camera is a matte focusing screen. This component focuses the light rays to absolute focus and clarity. With the matte focusing screen, the image is very clear and focused. Without the matte focusing screen, the picture would be very unfocused. Although the matte focusing screen is just one of the supplementary focusing devices in a camera, another part is the condenser lens.
Oh, I know. This basically focuses all the light rays together to form a parallel condensed ray arrangement, as you can see from this diagram.
That's right, Shield. Both of these devices help keep the image focused as it travels throughout the camera.
Okay, so I understand the matte focusing screen and the condenser lens, but I'm still a bit confused about what this pentagon is.
It's not a pentagon, Shield, it's a pentaprism.
Oh.
A pentaprism basically totally internally reflects the light rays that are incident towards the prism so that they exit perpendicularly towards the viewfinder, so that the person can view the image before taking the picture.
Oh, so that makes sense. So the incident light rays are past the critical angle, which results in this total internal reflection. Wait, but doesn't the image change when it goes through the pentaprism?
A pentaprism changes the image orientation because the rays that are incident from the condenser lens form an image that is inverted. What the pentaprism does is that it takes these rays and totally internally reflects them to rotate and form an upright image.
Oh, so this goes into the viewfinder. But what is the viewfinder?
The viewfinder is used so that the photographer can see the image before actually taking the picture. Because don't you want to see what the picture will look like?
Oh, now I got it. Thanks for telling me how a camera works.
Dude, are you kidding me? There's more to it.
Oh, so isn't it when you basically think that the picture's perfect, you just click the button and bam, there's your picture?
Not really. There's three things that happen when you press the button. The first thing that happens is that the reflex mirror pivots up another 45 degrees to a whole 90 degrees, which is parallel to the bottom surface of the camera. This prevents light from reflecting up towards the viewfinder. The second thing that happens is that the camera shutter opens.
Oh yeah, the shutter. I know about the shutter. So the shutter is basically two black curtains that does not permit light from entering the image sensor. When you press the button, the first shutter moves to the side, exposing light to the image sensor behind for a fraction of a second. Then, all of a sudden, the second curtain permits light from entering again.
So Shield, do you know what an image sensor is?
Oh yeah, I think I know. The image sensor is basically an electronic sensor, which senses the light and creates an electronic image.
That's right, but while also doing so, it inverts the image again to create an upright image. So here's a short overview of how the light passes through a DSLR camera.